Hello everyone. So this is the sixth problem from RMO 2019. This looks like a number theory problem, but it is actually a more or less combinatorics problem. So let me read the problem statement first. Suppose 91 distinct positive integers greater than 1 are given such that there are at least 456 pairs among them which are relatively prime. Showed that we can find four integers a, b, c, d such that GCD of ab equal to bc equal to cd equal to da equal to 1. So relatively prime also basically means GCD is 1. So what we know is there are at least 456 pairs. Let me write it down. There are at least 456 pairs with GCD 1. So we need to find ABCD according to the problem condition. So let us try to reformulate this statement. Suppose what we do is suppose let us call these 91 distinct integers as a1, a2. Let me draw by another color. So the 91 integers are a1, a2 up to a91. So these are the 91 integers. What we do is we denote each integer by node. So this is an integer a1, this is an integer a2, and so on. We represent each and every integer in this manner, and a3 and so on. Each and every integer is given a node, and if two integers are co-prime, what we do is we join them by line segment. So this is what we do, and there is representation for every integer. So there are a total 91 points, and we know that some 91 pairs are 456 pairs are co-prime by the problem statement. So what we know is there are 456 lines, and if we reformulate our problem statement is in this graphical manner, so what will happen is we need to show that a quadrilateral exists. So basically the condition which was given is AB equals BC equals CD equals DA equals 1. So suppose that these are the 4 points A, B, C, and D, and this is what the condition would look like. Note that we are drawing line segments only when two numbers are co-prime. So we have to prove that one of these exists. In our big diagram, one of these figures should exist, and this will prove our problem statement. So let us proceed by contradiction. Let's say by contradiction that no quadrilateral exists. No quadrilateral exists. So let us assume that, and we will try to disprove it. So if no quadrilateral exists, then what should happen? Suppose these are 3 points and these are joined like this, then there should not exist a 4 point which is joined like this. So basically, if we have 3 points like this and there is a fourth point, these two lines at least one of them should not be connected. So this is what should happen. So another way to formulate is that let us take a pair of points. Okay, this is a pair of points which are connected to a vertex. So suppose this is A1. So what we do is we choose let me write it down. We choose two two edges of A1. We choose two edges of A1. So let's say for example that this is A2 and A3. Like very general, I'm giving an example. So we choose two edges of A1. Then we choose two edges of, say this is some number an. So first we do this, we choose two edges of a1, then we choose two edges of an. So suppose this is an, and notice that this an, two of its edges must not be like this. Like a2 and a3, these 2 points cannot be the edges of an because otherwise a quadrilateral will form. So if we choose two edges of an, then because there are no quadrilaterals from these two, we can get one fact that the set we get from both cases should be different. So what this means is that suppose from this case, I'm writing it here. Suppose from this case, if I choose, suppose I get A2, A3, just for an example. And suppose from this case, the second case, we get some, say I say AI, comma AJ, then the set A2, comma A3 should not be equal to the set AIAJ. What I mean is that AIAJ cannot be exactly 2 comma 3. Like I comma j cannot be 2 comma 3 because otherwise see A2 would be connected to both A1 and A4 and hence we get a quadrangle which is not possible. So this should not happen. So from this we can conclude that if I choose two edges from A and I choose two edges from AN, then this set should be distinct. Like anyway, I will make a statement anyway to choose two edges of A, suppose AI, let me use another color, is distinct from choosing two edges of say another vertex AJ. Because say if one of the edges, like one of the way corresponds, one of the ways of these two, this thing and this thing are same, then suppose this is AI, this is AJ, and suppose this is some vertex x and y. So if x and y correspond to both a1 and aj, ai and aj, then this is the figure we get, and this figure forms a quadrangle, which is not possible. So this is what I mean to say. Any way of choosing two edges of ai is different from choosing two edges of aj. So what is the number of ways to choose two edges of ai? What is the number of ways? So this is simply ai choose two. So this is AI choose 2, which is AI C2, and this is AJC2, AJC2, and see this every single element corresponds to a different element from this. So hope you understand what I mean to say. So now let us consider a summation AI choose to from I equals 1 to 91. So notice that each AI choose to corresponds to a different each AI choose to corresponds to a different pair, because if some pair appears twice, then a quadrangle is automatically formed. So this should be less than equal to 91C2. See, 91C2 is the total number of pairs. This is total number of pairs. So this is the total number of pairs from 91 elements, and these are the pairs of edges we are choosing to be adjacent to AI. So because each of AI choose to counts for a different pair, so the total this represents the total pairs. Total pairs. Okay, this represents the total pairs which are adjacent to a vertex. For example, let me take a very easy example. So suppose this is A5 and this is A6. Then suppose this is A2. Then 5, 6. See, 5 and 6, these two elements, 5, comma 6, this pair appears only in A2. Because if it appears somewhere else, then as I said earlier, a quadrangle would be formed. So the total number of pairs this type of pairs is certainly less than the total number of pairs which are on the diagram. So the total number of pairs in the diagram are 91C2. So this sum should be less than equal to 91C2. So this is what we get. And let us try to solve for this. So this is what we get. So 91C2 is, let me, 91 into 90 by 2, which is equal to 91 into 45. So this is equal to 91C2, and this is greater than equal to AI choose to. Note that AI choose to can be written as AI square minus AI by 2, the whole summation. So what we get is summation of AI square minus AI is less than equal to 91 into 90. We multiply by 2 both sides, and summation of AI square minus summation of AI less than equal to 91 into 90. Now, what is AI? So actually I have made some error in measuring here, I mean notation here. So AI here represents number of edges adjacent to AI. So this is what AI represents in our above calculation. So see, the number of pairs we can choose for AI is AI choose to. So summation of AI square minus summation of AI is less than equal to 91 into 90. But notice summation of AI. What is this? What does this represent? So summation of AI basically represents twice the number of edges, because see, one edge, what it does, it's one edge. So suppose this is an edge, this counts for this vertex once and this vertex once. So each edge increases the total sum of this sum by 2. Each edge increases this sum by 2. So this should be equal to 2 times number of edges. Hashtag edges denotes number of edges. And what is the number of edges? The number of edges, as we have said earlier, is simply the number of pairs, because we have denoted edges by pairs. So what is the number of pairs? 456 is the number of pairs. So summation of AI is 2 into 456. Okay. So this is what it does. So what we get is summation of ai square minus 2 into 456 is less than equal to 91 into 90. So summation of ai square is less than equal to 91 into 90 plus 912. So this is what we get. But another inequality states that summation of ai square. So basically this is the AMGM inequality or Cauchy-Schwarz, anything you can say, that summation of ai square is greater than equal to summation of ai the whole square divided by n, where n is the number of elements. Here n is 91. So this is what we get. So this is equal to summation of ai square equal is like greater than equal to, what is this? Summation of ai is 456 square by 91. So this is what we get. And 456 square thus is less than equal to 91 square into 90 plus 912 into 91. So a quick calculation would show that this is a wrong thing. Like this is the equality. This is the sign that should hold. But unfortunately, the sign is reversed in our case. So this is not the true statement. This is contradiction. So hence, our assumption that no quadrangle exists is false, and hence one quadrangle should always exist, and hence we have solved the problem. So basically, this way of the main step was to articulate the problem in this manner. This is called a graph theoretic notation, like graph theoretic approach to this problem. So also we have used a very important method which comes time and again in maths, which is called this type of inequalities. This is called double counting. So we have used two concepts, double counting and converting a problem to graph theoretic language. So this was the problem. Thanks.